All right, so let's get started on today's class. So what we're going to do today is we're going to continue, it should be class 2, we're going to continue our look at chapter 2, where to start, where do we get our ideas from, where do we start doing this scientific experimental work that we're learning all these techniques in order to be able to do. So before we get to that, I just want to mention to everybody about the logic puzzles that are going to be incorporated into a portion of this course. So there's a link right now in Canvas in the modules section. You can find a link to this page here. And what we're going to do is you are going to encounter these as bonus questions on your exam. So I mentioned yesterday that deduction is one of the cornerstones of experimental psychology. It's one of the cornerstones of critical thinking. It's a skill that needs to be developed, but it's a skill that you will use across just about any field that you might go into. So it's incredibly important to develop these skills, and doing these logic puzzles is a nice fun way to just practice those skills. So what I would recommend is go to this site. You can actually log in if you want and create yourself a user account so that you can track what you're doing. But if you go to the logic puzzles and you click on that solve a logic puzzle, it'll get you here where you can select your puzzle parameters. And what we're going to be using for the exam is going to be the 4x4 grids like the ones we had in class. And it's going to be in the difficulty range of easy. So there's moderate and there's expert as well. But the ones on your exam are going to be 4x4 and they're going to be at the easy setting. So if you want to practice ahead of time, develop those skills, this is a great resource to do that. And the ones in the exam are literally downloaded from this site. So they're exactly the same type of questions that you can practice to make sure that you can maximize your skills and earn those bonus points. All right, so what we're going to be doing today, we're going to continue to take a look at our where to start doing experimental psychology. We're going to take a look at the sources of ideas. We touched on this last time, but we'll take a look at the sources of ideas such as theories and past research, observations of the world around us as well. And then we're going to go back to our look at induction and deduction. And this time, we're going to focus on the induction side of that, and we're going to have a little induction in class practice, talk about the final differences between the two modes of knowing, and then we're going to look again at our results from our in-class experiment. We just touched on those last time. We'll take a look at those in a little bit more depth this time around. All right, so sources of ideas. Where do your ideas come from? Sometimes students will ask me, well, how do you think of an experiment to do? And how do you think of the next thing to ask in psychology? And some of your ideas as a psychologist will come from theories. So theories are these bodies of ideas, these ways of organizing knowledge in a particular phenomenon. And they serve these two important functions. One is to organize and explain. So rather than a myriad of little observations, rather than maybe 20, 30, because we're humans, 1,000 different things to remember in order to understand behavior, you can organize them all into one category of behavior, one type of behavior, and that can be used to organize and then explain what is happening with that behavior. And then touching on the sources of ideas, they're also used to generate new knowledge. So oftentimes in psychology, and it's getting to be more and more occurring in psychology, what people will do is the same way that you are doing those logic puzzles, is they'll look at two theories, and by combining them together through deduction, they'll come up with new knowledge, they'll come up with new predictions, new expectations about the way that behavior will work. So theories are great because they organize and explain. It allows you to combine new ideas to form new knowledge. It allows you to see holes in current theories. So organizing all the theories in cognitive psychology allowed us to find that we really don't have anything that can deal with consciousness. So that's why a lot of work is being done with that right now. So that's one of the ways that it helps us to get this new knowledge. So just like you could use the theories or the information in these logic puzzles to deduce things that were not explicitly stated in the list of information, you can do the same thing with theories in the real world. And again, that's why we're practicing these so extensively. All right, the other source of ideas is past research. And this is your body of research on a topic. Most of the greatest contributions to psychology has come from people that understood what had occurred in the past and then asked themselves, what's the next step? What's the next thing that needs to be done? So there's a reason why we make you take courses in every single sort of branch of psychology for your degree, because you need to build up this body of knowledge about a wide variety of topics. So past research is your past knowledge on a topic, and basically when you know about an area of research, you can more easily identify what's missing, what's your next step, what's your next idea. So in terms of past research and theories, oftentimes, as I alluded to, you need to use deduction. You need to say, this is what one theory says, this is what another theory says, and if I combine the two, I can come up with this new idea, this new source of information, this new prediction, this new piece of knowledge. All right, so that was past theories and past research. Other sources of ideas are just observations of the world around us. Sometimes we just see things, see behavior, see phenomenon that are just catch our attention, and we just simply ask ourselves, what is going on? So observations of the world around us, that is induction. So if you notice something about the world around you, if you see a movie and you're sort of like, well, why is that movie incredibly popular? Why did so many people flock to Avatar? That's an observation of the world around us. And that might lead you to new ideas, new questions, new sources of information that you can then contribute to psychology. So observations of the world around us, unlike past research and theories, which mostly use deduction to get to those new ideas, observation of the world around us uses induction to get to its new ideas, its new theories. So that brings us back to induction and deduction. So we already looked at deduction last time, reasoning from general theories to particular pieces of data, reasoning from information to what was the start time for these individuals, what's their favorite souvenir, what medication do they need. So it starts with a theory and it ends with data. Once we're done today, I'll put up the answers to the previous puzzles from yesterday, but I want to make sure we got enough time for our induction. So what induction is, it's reasoning from particular data, particular observations, to some general theory, and it ends with a theory. So the classic example of induction is if you see a white swan. If you see one white swan, you might induce the theory that all swans are white. And if you see another white swan, you might say to yourself, oh, no, I've seen 2 white swans, all swans are white. And if you see 100 white swans, you might be very confident that all swans are white. So that is a way of getting from data to a theory. You just induce from your observations what you think the pattern is. And as we went through last time, this is part of the wheel of science, the wheel of knowledge, as I like to call it. So if you start with a theory, you then go through deduction, and you deduce what should be observed. However, you can also jump in on this wheel with something that you've observed, and from that you induce a theory that tries to explain it. But then once you've induced that theory to try to explain it, then you deduce a prediction to test that theory. And then if you have a new observation, you induce a new theory, which you deduce a new prediction, and so on and so forth, every single time getting closer and closer, hopefully, to the truth. I think my toolbar wants me to access something really, really bad. All right. So we saw the example of induction. I'll just do it one more time to get it fresh in our minds. Let's say that you have a friend, they're a painter, they're highly creative, and they're great at problem solving. They have low income, and they're introverts. They breathe in a lot of paint fumes, and they have slower cognitive functions. Let's say that those are all observations that you make about this individual. From those observations, from that data that you observed, you can get to a general theory. So you might induce the general theory that creativity in general leads to better problem solving. That's an induced theory. It's a theory that's about creativity and problem solving in general. You might also induce that people with low income are more likely to be introverts. He had low income, he's an introvert. Maybe in general, the theory, people with low income are more likely to be introverts. And then finally, breathes in a lot of paint fumes, has slower cognitive functions. Maybe paint fumes actually lead to slower cognitive functions. All of these are inductions from observations you made to general theories. All right, so what we're going to do now is we're going to do some induction in-class practice. And what I'm going to do is I'm going to set up the situation, and then we're going to try to solve this, once again, kind of working in groups. So we're kind of split up demographically in this, or by area here. So why don't we do this? Why don't we have the four of you will be in this group here. The three of you in the back, you can be in a group, and then the four of you in the middle, if you can come together and form a group as well. To do this, you're going to need a pencil and a paper so that you can write down your observations and you can write down your induced theories. So I'll give you a moment or two to move your desks around so that you can get in your groups so that you can discuss stuff. And we'll start up in just a moment or two. All right, so here is your situation. So imagine that you want to know the rule that is being used to generate sequences of three numbers. So let's put this in more of a psychology context. Imagine that you're a clinical psychologist and you get called up by a parent and they bring in their son and they say, something's wrong with my son. I don't know what it is, but he only speaks in sequences of three numbers. Right? So what you're going to do is you're going to be given some data. And once you have that data, you're going to induce a theory from that data and then deduce a prediction from that theory. So you're going to start off with a sequence of three numbers. You're going to try to induce a general theory that explains the pattern of numbers that this person is going to say. And then from that, you're going to deduce what they might say next. Right? What might the next words or numbers be out of their mouth? Once you have that theory and that prediction, put up your hand. I'll come to you, and I'll let you know if the prediction fits the rule. So is the prediction something that this individual would say? And I'll also let you know if your induced theory is something that this individual would say as well. So we'll start this in just a moment. I'll tell you his first sequence of three numbers. But what we're looking for here is not the cause of his behavior, but a description of the symptoms of his behavior. And what I mean by that is we just want a rule that covers what is he saying, but not why is he saying it. So theories such as, well, maybe he had an injury to his temporal cortex, so that his speech processing is off. theories like that are why he might be saying this. We're not quite at that level yet. We first want to understand the symptoms. So we first want to know, what is he saying? What's the rule that's governing words that are, numbers that are coming out of his mouth? So that is your challenge for this exercise. So is that clear to everybody? All right, so he walks into your office. You say, welcome to the office. Why don't you take a seat? And he says, 246. So that is your first piece of data. So what you want to do now, and discuss this in groups, you want to induce a theory from that data and then deduce a new prediction. What might be the next three numbers that he says? All right, so as we're kind of working on this, I'm just going to mention real quick, one of the things that that often happens in this exercise is that groups will get stuck on the idea of even and the idea of even numbers. And it's happened to every group so far where they'll say things like, well, maybe he only says even numbers, and that's not the case. Maybe only numbers that increase by 2. It's like, well, that's not the case. Maybe numbers that can only be divided by 2. It's like, well, that's just even numbers. So if something like that keeps failing and doesn't keep working, one of the things that you can do to kind of move yourself forward is try something a little bit off the wall, a little bit crazy. So we actually had two groups that did try theories that were kind of came out of nowhere, right? But they gained really good knowledge by trying these weird, wacky ideas. So try something weird, try something wacky. It might work, it might not, but you get knowledge either way. You can get closer to the truth by either knowing that it's in this direction, or even more importantly, knowing that it's not in an opposite direction. Okay. All right. Well, if we had a little bit more time, I'm sure you guys would zone in on it. But in the interest of making sure we got enough time to take a look at our data, we're going to call it at this point. So let's go over the solution. So there was the data that you started with. And this is actually, if you are interested in taking a look at some more of the theories behind this, Wason did this study back in 1960 on the failure to eliminate hypotheses in a conceptual task. The final answer, and we had a couple of groups that got it, the final answer is this is just any ascending sequence. So the rule here is that it's any three numbers where they're in order of ascending size. So 246 is something he would say, 123 is something he would say, 43,000 and 1,857,263 is something he would say. So it's any three numbers as long as they go from smallest, middle to largest. That's the rule. So a couple of things to point out here. Number one, I hope that this experience gives you a kind of insight into the challenges that come with trying to delve into new areas, trying to push the boundaries of psychology. It's very difficult to go places when you don't know the answer, and that's something that you experienced in this situation here. Also, I'll point out that one of the things that makes this so challenging is once we kind of grasp onto an idea, oftentimes it's very difficult to get away from that idea. So most students, when they do this, they start off very reasonably with the even numbers going up by 2s, but then they kind of get trapped in that, it has to do with 2s kind of situation. So it's going up by 2s, it's even numbers, it's divided by 2, it's and they kind of get trapped in that. And just like in this example in psychology, sometimes the greatest kind of steps are made when you basically say, I've been thinking about this way for a while, let's discard that and try something completely new, completely off the wall, and that helps propel the science forward. And then the last thing that I wanted to say, I might have forgotten what it was, but I'll see if I can bring it back while I'm drinking. No, I think it's gone. All right, so we'll move on. If I remember what it is, I'll mention it. But let's move on to a final induction, deduction, final differences wrap up, just so that we're very clear on what can be done with induction and what can be done with deduction. So, excuse me, as ways of reasoning, as forms of reasoning, deduction is what is known philosophically. We're gonna talk about this in terms of philosophy right now. It's what is known as a valid form of reasoning. And what that means, it's got a very specific meaning. It doesn't mean what it means in English. It means what it means in philosophy here. What a valid form of reasoning means is that if your theory is correct, then you are guaranteed, if you do deduction correctly, you are guaranteed that your prediction will be correct as well. So again, a valid form of reasoning is that if you start with correct information and you apply the reasoning, you're going to be guaranteed that your answer is going to be correct. And we saw this with the logic puzzles. If you do the logic puzzles correctly, you are guaranteed to find out who had each souvenir, who was on what medication, who arrived, finished the race in what position. That is going to happen 100%. So deduction is like a math problem. 2 plus 4 equals, if you know the rules, you will get to the right answer every single time. Deduction is known as a valid form of reasoning. Now, induction, on the other hand, is what is called an invalid form of reasoning. And again, this is a very limited philosophical definition. And what an invalid form of reasoning is, it means that if your data is correct, then you're not guaranteed that your induced theory is going to be correct. So we saw this today. So many times I was called over to a group and they had a new theory, and that theory fit everything that they had so far. That theory fit all the data. So that it was so the data was correct, induction was applied correctly, and yet most of the time I would say that's not the reason he's saying those numbers, because your final theory that you induced was incorrect. So induction, for that reason, is known as an invalid form of reasoning, where even if you start with correct observations and you imply induction correctly, you got no guarantee that your theory is going to be right. And that's why it's a constant circle between these two, because you induce a theory and then you make a prediction, and if your theory is correct, you should find that prediction. And the reasoning is that if you don't find that prediction, that means your theory had to be incorrect. So you go back, and what do? You try to come up with a new theory. And that's why you'll see so many different theories in psychology, as people keep trying to go around and around and around and around, trying to get to the truth of what's going on. All right, any final questions on induction and deduction before we wrap that up? All right. Okay, so we're going to take a look at our data one more time. We're going to take a look at it with a little bit more detail this time around. So before we do that, just once again, this quick reminder about what inferential statistics is doing. And the importance of inferential statistics as well. So inferential statistics, all it tells you, its bottom goal, its final destination, is to just tell you whether a difference that you see between conditions, is that a real difference, that is a real psychological difference, or have you just created a difference due to chance? Okay, so if you want to put this in terms of the kind of classic coin flip situation, if you were to take a coin that was fair and you were to flip it 100 times, you would expect that 50 times it would land heads, 50 times it would land tails. But what if 51 times it landed heads and 49 times it landed tails? Would you then say, oh, that's an unfair coin? Probably not. You would probably say, that's just due to chance, right? We got a 2 flip difference, it could happen. On the other hand, if you flipped it 100 times and it came up heads 90 times and tails only 10 times, then you would say, that's not random, that's not chance. Something's going on here, that's an unfair coin. So remember that, remember the girls trying out for the basketball team where you're trying to find out which of these two is the better player. If you play them head to head and this girl beats this girl 20-1, that difference is so big, that is very unlikely due to chance, to random factors, to lucky bounces. This is probably due to the fact that this girl actually is a better basketball player. So inferential statistics will take a look at the size of the difference between two groups when it's considering whether the difference is real or whether it's due to chance. If that was the result after one game of one-on-one, then inferential statistics would take a look at this and it would say this result is probably due to chance. She's probably no better than this girl over here. That is a small difference, is probably due to chance. And this is very important to remember because sometimes when you're reading the data, when you're interpreting data, your human mind has been so trained to know that this number is bigger than this number that it's kind of hard to retrain it to say that, oh no, these numbers are really the same. It's just a difference due to chance. But that's what inferential statistics tells us, and that's what in the end we're going to have to communicate to our readers when we write our report. And then lastly, inferential statistics takes into account the regularity of the results. So if there's not a lot of variation, even if the results or the difference is very small, if it's highly reliable, inferential statistics will once again say she's the better player than her. This difference is small, but it's so regular that it can't possibly be due to chance. So that's all inferential statistics is all about. So now that we know that, let's take a closer look at our data. So we're going to get into the idea of main effects, and we're going to get into the idea of interactions in a little bit. I just want to touch on it right now. So these are the results from the in-class experiment. And what we got here on the y-axis is percent recall. This is the percentage of words that you recalled during the recall session. So it's out of 100. If you recalled 100% of the words, that means you recalled everything. If you recalled 0% of the words, that means that either your page was blank or you didn't remember any of the words. So here we have the effect of item type, and we have the effect of item type alone. So that's what a main effect is. It's the effect of each variable that you have in your experiment isolated, alone. So we had two different types of items. We had correct items, words that were actually on the list. We had critical items, words that were not on the list, right? These are the false memories. And we also had another variable. We had groups. We had, were you in a group of 3? Were you in a group of 2? Or were you doing this individually? We had 3 different sized groups in this experiment. In a main effect like this, what it does is it takes the data from all 3 groups and combines it into one score. So this bar here contains the individuals, the pairs, and the groups of three, and their performance on correct words. This bar here contains individuals, pairs, and groups of three, and how many false words, false memories did they recall. So this is the data right here, and to my human eye, I would take a look at this and I would say that's a real difference. Our minds are actually truly better at recalling correct information than we are at making false memories. So does everybody kind of agree with that? It seems reasonable? Okay, so it is actually reasonable, and this is one of the instances where what we kind of think matches up with what inferential statistics tells us. So in these graphs in your notes, the green connections, those means groups that are different, statistically different. Inferential statistics says this is different. So we are actually better, our minds are actually better at recalling correct information than we are recalling critical information. So that's nice to know, right? It's nice to know that most of our memories are true memories, and we're not walking around with, tons and tons of false memories. However, notice just how high those false memories were, just under 40%. So just about 2.5 words per 6 false memories were recalled by people in this experiment. So this experiment was specifically designed to create these false memories, but it's sobering to know that so many false words were recalled in this particular experiment. All right, so I talked about the main effect for item type. This is the main effect for group size. So this is the percent recall for people working alone, percent recall for people working in pairs, percent recall for people working in groups of 3. And these bars make a little bit less sense because each of these bars is a combination of the words you recalled correctly and your false memories. So this is almost just how much recollection did you have, how much memory did you have, whether it was right or whether it was false, what was the total amount of things that you remembered. And as you can see, there doesn't seem to be a lot of difference between how much singles, pairs, or groups of 3 recalled. And in reality, there isn't. So inferential statistics told us that these differences, these small little differences, so you can see just a little small difference there between pairs and just a small difference between pairs and triples, inferential statistics told us that is due to chance. Those 3 groups are actually all exactly the same, which kind of seems a little weird because you would expect maybe pairs and groups of 3 to recall more than singles did. But in this main effect, we see that that difference is actually not significant. It's actually just due to chance. Now, I mentioned that it seems that way because the real story, the final story, actually isn't that case. The final story comes out in the interaction. So whenever you have, and we're going to spend a lot of time on interaction, whenever you have 2 variables in an experiment, you have the potential for those variables to interact, right? And an interaction, one of the easiest ways to understand the idea behind an interaction is to think of drug interactions. So if you've ever had a prescription medicine that was prescribed to you, usually your prescription medicine will say something like, do not take this with alcohol. Why don't you want to take it with alcohol? Because of these drug interactions. So the prescription medicine on its own has the effect of curing your disease. Alcohol on its own has the effect of lowering your inhibitions. But the prescribed medicine with alcohol has the effect of sending you to the hospital, right? Not curing your disease, destroying your liver. So that's an interaction because there's nothing to suggest that curing your disease, that's great. Lowering your inhibitions, that's great. Why wouldn't I take the 2 together? I'd have a cured disease and I would have lowered inhibitions. No, you don't, because the 2 of them interact, and that is why we run these 2 variables together. So much like that drug interaction, we're looking for pair versus type of memory interactions, and that actually comes out here. So once again, we got percent recall. Once again, we got the group sizes. We got people working individually, people working in pairs, people working in groups of 3. And then you can see up here, the blue bars, these are the correct words, correctly recalled words. The red bars here, these are the false memories. And the statistics, inferential statistics told us that for correct words, we actually get that 2 heads is better than 1 and 3 heads is better than 2 effect. So groups of 3 remembered the most correct words, and that was followed by groups of 2. And groups of 2 were better than groups of 1. So if we were looking to answer the question, are groups better at remembering words? Are 2 heads better than 1? We would have come up with the prediction that pairs should recall more than singles, and lo and behold, that's what we found. And then if you take a look at the critical words, if there was no interaction, then it should follow the same pattern. But it doesn't. It actually looks like it follows the opposite pattern. It looks like these differences should be significant. But as we saw last time, inferential statistics says, no, those bars are actually no different from each other. These bars here do not indicate a real difference. The only reason that they have these different heights is due to chance. So this is one of the reasons why statistics is so important, because to my mind, that looks like groups of 3 have fewer false memories than pairs. Pairs have fewer false memories than singles. But that's just taking into account the size of the difference, not the reliability. You take both of those into account, and it turns out that single individuals actually recall just as many false words as pairs and just as many false words as groups of 3. All right, so that's one half of the results. Any questions about that? No, does it all make sense? Is the picture kind of forming of what happened? All right. So hopefully you remember in the experiment, not only did you write down the words you could remember, but you also rated them in terms of how confident you were in those recollections. So let's take a look at that confidence. So first off, we'll once again start with item type. We got correct words over here, words that were on the list. We got critical words over here. These were the false memories. And we got confidence over here. So confidence can go all the way to a maximum of 4. That was the maximum amount of confidence. Minimum was a confidence level of 1. And as you can see, once again, thankfully, we are significantly more confident about our correct words than we are about our critical words. So we are more confident in the words that we remembered and that were true memories, and our false memories had less confidence. But once again, even though this is significantly different, notice that for our true memories, we're looking at like 3.8, 3.9. For our false memories, we're like at a 3.2. So it's not like you're really unconfident about your false memories. You're just slightly less confident about your false memories. And you can't get to 3.2 without 20% of individuals at least saying, yeah, I'm 4 out of 4 on this. I'm 100% confident for this memory. So critical false memories actually had pretty high confidence. Thankfully, though, our minds are working well, not as confident as our correct words. All right, what about our groups? How did our groups do? So now we got single individuals. And again, these are a little bit hard to interpret because this combines correct words and critical items. This combines correct words and false items for pairs. This combines correct words and false items for groups of 3. But let's just make the analysis complete. As it turns out, once again, I would take a look at this visually and I would say singles probably going to be different than pairs and groups of 3. And inferential statistics says, yes, they are. So singles actually do have less confidence for their memories in general than do pairs and groups of 3. And pairs and groups of 3, they do not differ between each other. So it seems like the key factor here is whether or not you're working alone or whether you're working in a group. You're working alone, lower confidence for your memories. You're working in a group, higher confidence for your memories. So far, so good? All right, last result. So, this is one of the most intriguing ones. I think this is one of the biggest results here. So we have, once again, singles, pairs, and groups of 3. And we have correct items in the blue, and we got critical items in the red. So words that were on the list, and these are the false memories, those 6 words that were not on the list. And the first thing we'll see is that inferential statistics has shown us that for the correct words, individuals, pairs, and groups of 3 have the same confidence. So when they're correct, individuals are not lower in confidence than any of the groups. When they're correctly recalling things, individuals have just as much confidence as do groups. However, for the false memories, for the incorrectly recalled information, singles actually have significantly, truly less confidence than do either pairs or groups of 3. So if you are remembering things in a group and you falsely remember things in a group, you will attribute way more confidence to that false memory than you would if you were recalling things alone. And it doesn't matter what the size of the group is, because pairs and groups of 3, they actually have the same amount of confidence for their false memories. All right, so everybody kind of got the picture of what happened in the experiment? Any questions on what occurred? All right, so the last thing I'll mention today, and then we'll wrap it up, is so far with this data, it's very interesting, it's very cool. I like it, I like numbers, I like stats. But if this was all that it is, once again, it's kind of a little parlor trick, right? Once again, if this is all that it is, I could say things like, well, if I put you together in pairs, you're more confident about your wrong answers, haha, ta-da, right? It's like almost like a horrible magic trick that you wouldn't want to watch, right? So that's if it stays here. The key to psychology, the key to science, the key to experimental psychology, the importance of it is what does it mean beyond the lab? So what I want you to do as we go through this is try to think about situations in the world where people are trying to remember things either individually or trying to remember things in groups. And based on this data that we have, based on these differences that we've seen, is it a good idea to do it that way? Or is it dangerous to do it that way? So for example, in the jury system, right? We have 12-person juries trying to make decisions and remember all these details about what they heard in a court case. Does this say that that's a good idea? Or does it leave it open to potential for miscarriages of justice because of false memories creeping in? If you take a look at on social media, the rise of conspiracy theories, the rise of pseudoscience, right? That didn't happen prior to social media. Can we explain what's going on in terms of what we have here, in terms of the higher confidence, for groups? If you were a therapist and you were dealing with people who were trying to recover memories from their childhood, right? Maybe they experienced a traumatic event and they were trying to recover memories from their childhood. Would it be a good idea to do this therapy in a group setting? Or would that be an incredibly horrible idea to do it in a group setting based, again, on this data? So if you think about it in that way, if you think about it in terms of that impact, the impact of somebody getting sentenced to 20 years in prison versus being set free, the impact of conspiracy theories and violence against minorities and people not vaccinating their children and flat earthers and climate change denial. If you look at it in terms of people receiving therapy that could either help their lives or destroy their families. If you look at it in that terms, then this goes from that little ta-da trick to an incredibly important piece of information to help us help people and make the best out of their lives. So as we go through this course, this is the data that we're going to be working with. This is the experiment that we're going to write up. We're going to learn how to put all those pieces together. But continually think about this because it'll come up in the discussion. As you see, just in your daily lives, if you see a news piece, if you hear a story from your friends, and it has something to do with group memory, group cognition, just take a moment and say to yourself, what might my experiment have said about that group theory? Is that what we should be doing based on the data that we ran in this experiment? All right, are there any final questions, thoughts, comments, anything before we wrap it up? All right, so that is it for today. So I will, this is, again, remember that these lectures, if you need to watch them again, are available through your McGraw-Hill Connect. So take advantage of that. But other than that, we are done for the day.